I'd like to talk about two of the homework problems. First off, problem 840. We have information that the diameter of men's heads follows a bell curve, and the mean is given to be 7 inches, and the standard deviation is given to be 1 inch. And the question is, find the probability that the diameter of the head is somewhere between 6.5 and 7.5 inches. To do this, we convert both 6.5 and 7.5 into standard units. So 6.5 minus 7.5 over 1 less than or equal to z, or sorry, 6.5 minus 7 over 1 less than or equal to z, less than or equal to 7.5 minus 7 over 1. So that's the probability that z is between negative 0.5, 0.5, and plus 0.5. So I need the area between negative 0.5 and plus 0.5. So to do that, I need the area to the left of 0.5 minus the area to the left of negative 0.5. If I use Excel, this will be equal to norm S dist 0.5 minus norm S dist of negative 0.5. You have a slightly different formula using the TI calculator, or of course you can use a table, but either way you should get an answer of 0.3829 as the area. So the chance of this happening is about 0.3829. So that's part A. To do part B, the question is 99% of the men will have heights between blank and blank. Alright, so to do this time the percentage is given, and what's given is that the area in the middle from here to here, say, is 99%, and the question is what's the value of z that goes with it. So if 99% of the area lies in the middle, that means 0.5% lies in the left tail and 0.5% lies in the right tail. So the area to the left of z is going to be 99.5%. So the value of z for this problem will be equal to norm S inv of 0.995. And a similar command if you're using a calculator, we get 2.5258. Then to convert to x is equal to mu plus sigma times z. So in this case, the mu was equal to 7 inches. So 7 plus 1 times this for 9.5758. So that's the x value, the number of inches. So that's the value that you see on this side. Now I need two extremes. The other extreme that I need is the number over here, and that's going to be negative 2.5758. And so the x that goes along with this one will be equal to, again, mu plus sigma times z. So that's equal to 7 minus 2.5758, which subtracting we get 4.4242. So the z values are going to be from negative 2.5758 to plus 2.5758, and the corresponding x values go from 4.42 inches to 9.58 inches. The part C of this problem concerned that 2% of the customers will have sizes greater than something. So I want the area to the right this time to be equal to 2%. That means the area to the left is 98%. And so I use the norm S inv again to figure out the value of z that goes with it. So for this problem, it'd be norm S inv of 0.98. 2% of the area lies to the right, which means 98% of the area lies to the left. So the z value will be equal to 2.053. Then converting to x's, x is equal to 7 plus 1 times the z value I just got. So doing the arithmetic, I get 9.05. Actually, let's put 37 inches. So 437 inches. So that is problem 840. The other problem that caused difficulty was the idea of using calculus to find the absolute maximum and also the points of inflection for the normal curve. So let's do that one fairly quickly. F of x is equal to 1 over square root of 2 pi times e to the minus x squared over 2. To find the absolute maximum, we first find the critical points, which we obtained by taking the derivative and setting the derivative equal to 0. The derivative, well, let's see. 1 over square root of 2 pi is a constant, so that just simply comes along for the ride. The derivative of an exponential function is the exponential function times the derivative of the index, or the exponent. The derivative of negative x squared over 2 is negative x. So I take the derivative, I set the derivative equal to 0, and solve for x. Well, let's see, 1 over square root of 2 pi cannot be equal to 0. An exponential can never be equal to 0. And so the only thing that can be equal to 0 is this part, which means x is equal to 0. So that is the critical point. Then, to show that it's an absolute maximum, we look at 0 here. If I plug in a number that is less than 0, if I plug in a number less than 0 here, that's positive. E to the anything is positive, and if x is less than 0, negative a number less than 0 is positive. So for numbers that are less than 0, the derivative is positive. By the same logic, if I were to plug in a number that is bigger than 0, I would get a derivative that's negative. So here it's increasing, and here it's decreasing, which means 0 is the absolute maximum, is the only critical point. And so it's a local maximum and therefore must be the absolute maximum. So that's to show that it's an absolute maximum. Now let's talk about how to find the points of inflection. To figure out the points of inflection, we take the second derivative and set the second derivative equal to 0. So the second derivative, by the product rule, that's equal to, well, let's see, the 1 over square root of 2 pi is just going to come along for the ride. So I'll just factor that constant out. I have the derivative of the first. So there's the derivative of the first. The derivative of this piece times the second. So that's the extra negative x there. Plus the first. Times the derivative of the second. And so factoring, we get 1 over square root of 2 pi e to the minus x squared over 2 times x squared minus 1. Negative x times negative x gives me x squared, and the negative 1 comes here, equals 1 over square root of 2 pi e to the minus x squared over 2 times x minus 1 times x plus 1. So it looks like we have possible points of inflection at -1 and at +1, where the second derivative is equal to 0. To confirm that this actually happens, let's do a quick sign chart. We have 1 over square root of 2 pi is times e to the minus x squared over 2. That's part of the second derivative. So let me mark down here that this is the second derivative. We also have x minus 1, and we also have x plus 1. The points of interest are -1 and +1. The first term is always positive. 1 over square root of 2 pi is positive, and e to the anything is always positive, so that first bit is always positive. So x minus 1, that's equal to 0 at 1. It is negative if I plug in something that is less than 1, and it is positive if I plug in something that is bigger than 1. X plus 1, that is 0 if I plug in -1. It is negative if I plug in something that is less than -1. And it is positive if I plug in something that is bigger than -1. So that means that the second derivative, multiplying, is going to be positive over here. It's 0 at -1. It's negative. Positive times positive is negative. And let me make this in red to make it stand out. Positive to the left of -1. 0 at -1. Positive times positive is negative. Then 0. Positive times positive makes positive. So the graph here is concave up, concave down, concave up, which means that -1 and +1 are the points of inflection. And indeed we see that in the graph, that the graph goes like this. The changes concavity at -1 and at +1. Here it's concave up, here it's concave down, and then over here again concave up.